So in the first part, it's going to be an overview of what Agentic or Agent AI systems are and how it works and when to use it.
Don't forget to give us likes, leave your comments, share us to your friends, and also subscribe to our channels. We have YouTube, LinkedIn, TikTok, and Facebook.
So this table actually plot or have in rows a level of AI that can assist in your program. On the top part, you have an assistant level, and the bottom part, you have extremely or most for agentic part. The key difference is how much you are allowing the AI to automate the work for you. On the top part, you are working in the assistant agent. So AI doesn't have any autonomy in doing or progressing the work. At best, you are using it as a recommendation for you to do the work well. As an example, in this one, the AI or the LLM output has no impact on the program flow whatsoever. As a human or a deterministic software actually see the recommendations or some output from the AI, but the system or you still has full control in what the program should flow. Maybe one step up, the LLM or the AI output will determine which program path to take. And this is something like if the LLM decision is true, we take path A, or else we take path B. And then the second level, the LLM output actually determines function execution. So for example, the LLM might output that, okay, retrieve the information from this link. And then your program, deterministic in this sense, or being controlled fully by you or your programming, will trigger a tool to retrieve information. So this is actually in the realm of assistant, right? And you are progressively giving more control to the AI so that it can design which action to take. On the bottom part, you are entering a more agentic regime where AI decisions or LLM's output actually control more and more of your programming path or flow. As an example here, we are having something called the multi-step agent. Multi-step means the AI or the agent does multiple steps. Sometimes you program it, the orchestration layer, you take a look at it later. The way the framework is coded allows the agent to iterate its thinking and its action in a loop. So here, the LLM output controls iteration and program continuation. So you can, the AI can decide, okay, I need to continue. I need to continue more because I haven't done the task yet, right? And this is what we are going to take a look today, especially this repo called small agent. Now, the ultimate form, at least in the ultimate, in the sense that, well, the ultimate that we know now, is the agentic system where there are many multiple multi-step agents working together, and this is going to be the network of multi-agent coding, right? So typically, the tools that I would recommend you go in choosing when you want to build agent systems is going to be like LangGraph, CrewAI, AutoGen from Microsoft. And the last one that I will introduce because it's fun is the small agent from Hugging Face. But before we actually arrive at the end of the technical part of small agent, we have to go through the introduction of what multi-step agent is. So in this slide, on the left-hand side, you will see components in making performing multi-step agent systems. The agent needs to have memory because it needs to know what the task is, what it has done in the past, what actions work, and what action did not work, right? The agent is going to use something called a React. A React is a framework, pretty much it's a prompting framework, forcing the LLM to think. The re part stands for reasoning. So the LLM or the AI will start reasoning the task. And when reasoning, it will arrive at what action it needs to do, and therefore the act here. So basically, the React framework will ask or guides the model, the AI, to reason what it needs to do and perform the action and get the result from the action and keep doing it in a loop. Now, the action is usually conducted in tools, right? Tools can be many things. Calculating tool, a Python coding tool, a web search tool, a SQL database retrieval tool, RAG retrieval tools. Tools are actually something that provide uh, models access to external information that it needs, right? Now, the looping part is essential because you want the model to solve the problem in steps. Some problems require multiple steps to the end to finish. Therefore, a loop is necessary. But then, most of the time, or not most of the time, but sometimes your agent is actually stuck because the reason can be that the tools that you provide to the agent are not enough to solve a task. And therefore, the agent will keep being stuck in the loop. And then it makes more sense for a programmer to define a termination criteria. And typically, the termination is, oh, the LLM has finished its task completely. Then the loop will stop, or it has hit the maximum number of steps that is allowed to do. And then the whole agent multi-step agent loop is terminated. And when you let's take a look at how it fits together. The LLM will start with system prompts, right? And then it's given a task. Initially, this is the memory stack. Initially, the memory stack will be empty, but when it has in the loop of the multi-step solving task for a while, the memory is going to be appended, and you get this memory, non-empty memory. So now with the full prompt, with the system prompt added with memory in it, it's given to the LLM, right? And the LLM now judge whether what kind of action it needs to do. In this sense, in this case, it actually thinks that, okay, I should return the result. And then it takes an action. All right, use this function to return the result. And if everything is fine, this loop is exit, right? Now, in terms of use cases of agents, well, I need to remind you that not all of your problems should be solved by AI agents. There are many reasons for it, but in terms of engineering, the simplest solution that works is the best, right? Sometimes you can just need a deterministic program to solve your problem. But when the problem that you need to solve is more flexible and it's getting harder and harder to write down deterministic paths, maybe there's so many paths to cover, then you are running into a problem that needs flexibility. And that's where agentic AI comes in, right? So in the literature, actually, a lot of experiments, maybe white paper out there, have shown that most suitable cases of use cases for agentic AIs can be like this. The first one is automated customer support. Well, this task is complex. It needs flexibility. You cannot really write a deterministic program to handle incoming customer queries. Therefore, an AI agent is suitable for this task. And this doesn't have to be a customer-facing customer support. Customer can actually means your employees. Well, typically, if your organization is big, you are going to have an IT department, and the IT department needs to solve lots of IT related issues from maybe like thousands of the employees. And usually you will adopt a ticketing system where employees submit a ticket, and then the IT personnel need to come in and respond, right? So with the agent, it actually can solve some parts of the tickets automatically, because the most part of the tickets are going to be like relatively straightforward. And this is the perfect case for AI agents to actually be deployed in production, right? first one is automated customer support. The second one is coding development agents, AI agents that help you develop your code, acting as a software engineer. This is great because you can measure the performance of the agent. Well, if the AI agent writes a good code, then the code should pass the test, right? The unit test and whatnot. So another part of a criteria for adopting AI, agentic AI system is that you can measure the performance of the AI well. Both of the customer support and code development agent, they are straightforward in measuring the performance of the AI. Similarly, marketing copywriting tasks are suitable as well. This actually involves a lot of iteration between the LLM and the environment, where the environment will maybe replaced with an evaluator LLM, another LLM that give feedback to the writer LLM. So this iteration works for a marketing copywriting or any kind of like creative writing that needs to be revised. For performance, you can actually measure this with the LLM as a judge. The LLM can judge whether this copied the writing, the draft is good or not, right? So performance evaluation is quite straightforward here. Well, last but not least, deep research and automated research. And this has made popular by first Gemini 2.0 that released deep research in the Gemini advanced offerings, and now OpenAI and even Perplexity followed up with the deep research kind of thing. So this is great because in doing deep research, you will need to actually look into many sources, gather information, and write a summary. And if you can automate that, that's fair. This is great. And this is where, therefore, the AI agentic systems is the appropriate in this case as well. All right, that's pretty much it for the high-level understanding of agentic AI systems and the use cases that are fit for its task. So just to summarize everything, when you want your program or the problem to be solved deterministically, you probably want to work with the assistant level where the program control or flow is little controlled, little affected by the AI. But if you're running into a very complex and or a problem that needs flexibility, then you need AI to have more say in the flow, and therefore you are allowing the AI to take more control in the program flow and the function execution. So make a judgment on your application or what you want to do and decide whether you want a deterministic, highly controlled environment where AI has no control, or a automated agentic system where you allows the AI to have its autonomy.